Think about how we actually measure success, whether we're grading a line of code or, say, evaluating the neural pathways of a human brain. The standard tools we use to define competence might actually be hiding this massive structural flaw. Welcome to today's Explainer. We're going to dive into a super surprising and honestly totally hidden parallel between how we evaluate machine learning algorithms and how we measure human cognitive genius. It turns out our absolute most sophisticated systems, both artificial and biological, are getting crippled by the exact same trap. So let's unpack exactly how this happens and, more importantly, how we can actually fix it. To kick off this Explainer, we really need to unravel a central mystery here. What exactly connects an artificial intelligence algorithm that just completely crashes and burns when it hits new data with a burned out, twice exceptional human mind? I mean, on the surface, right? Computer science and human psychology seem like completely unrelated domains. One is running on silicon and code, the other on neurotransmitters and synapses. But if you look deep down, they suffer from the exact same structural bottleneck. Literally, they are both victims of a fundamentally broken evaluation system. So the core culprit in both of these fields is something called the fallacy of the flat baseline. And the crucial point to remember here is this. Whenever you take complex, highly specialized, or, spiky data, and you try to just force it through a standard, lossy, one-size-fits-all channel, you are guaranteeing catastrophic system failure. It's basically like trying to shove a three-dimensional object into a two-dimensional slot. It just doesn't work. In the AI world, this happens through something called uniform random sampling. This assumes everything is uniform, which totally hides the model's blind spots. And in human society, well, it happens through standardized public baselines. These baselines completely devalue unique, non-traditional cognitive assets. The richness of the original data is just destroyed, all by the very metric that's trying to measure it. Let's start over on the machine side of things just to see how this plays out. Standard natural language processing, or NLP, evaluations tend to rely heavily on that uniform random sampling we just mentioned. And this is a testing method that, quite naively, treats every single piece of test data as if it's exactly the same. It implicitly assumes all data instances are equally representative of the real world. Think of it kind of like assuming a dense, highly complex medical journal is just as easy to read as a children's pop-up book, simply because, well, they both have pages. Right? By treating all data as identical, this assumption completely hides the AI's actual blind spots. It creates this really dangerous illusion of competence during the testing phase that just instantly falls apart the second that model goes live in the real world. And the sheer scale of this problem is absolutely staggering. When researchers tested 125 different models on the widely used SQUAD dataset, they made a wild discovery. They found that specific data dimensions, like the sheer ambiguity of a text or its point-wise difficulty, caused massive F1 score swings of 6 to 12 points. Now, if you're not familiar, the F1 score is essentially the gold standard grading metric for AI accuracy. So a drop of 6 to 12 points, that is not just a minor blip, that's a catastrophic failure in prediction. It definitively proves that the underlying distribution of the data actually matters way, way more than the evaluation metric itself. Basically, if you don't understand the texture of the data you're feeding the machine, your accuracy scores are practically meaningless. Okay, so this brings us to a truly fascinating and honestly pretty sobering parallel in the human experience. Twice exceptional, or 2E individuals, possess these elite, highly specialized, spiky cognitive assets. And when we say spiky, we're talking about people who might have off-the-charts genius in pattern recognition or systems thinking, but who might really struggle to navigate, say, standard social small talk or standardized testing. These minds end up facing a severe socioeconomic bottleneck. Their incredible specialized skills get heavily suppressed and frankly devalued by an infrastructure that's just strictly optimized for low complexity, flat baselines. It's exactly like the AI failing on unexpected data. The true capabilities of a 2E human get completely hidden by a flawed, rigid environment that demands uniformity over actual brilliance. And the biological cost of this mismatch is extreme. As the source text points out, whenever a 2E individual tries to transmit their complex, uncompressed emotional or intellectual data through those standard, low-fidelity social channels, it actually triggers a literal physiological response in the person listening. Specifically, it triggers an involuntary KATP bioenergetic freeze. What does that mean in plain English? Well, the receiver's brain literally shuts down from the energy overload. Their neurological system just gets completely overwhelmed by the sheer density of all that spiky data, and it acts like a biological firewall. So the connection just drops to zero, resulting in absolute 100% data loss. The genius is quite literally lost in transmission simply because the receiver's hardware can't process the signal.
So how do we actually fix this broken evaluation matrix? Going back to the machine side for a second, researchers realized they absolutely had to abandon those flat baselines. So they developed a framework called benchmark transparency. Instead of just lazily treating all data as uniform, they systematically measure it across 6 independent dimensions. We're talking about things like how ambiguous a text is, or how much label noise, which is basically disagreement among human annotators, exists within the dataset. By scoring the data across these really distinct metrics, things like difficulty, discriminability, length, and perplexity, we finally get a full 3-dimensional scan of what we're actually testing our models against. We stop just looking at shadows on the wall, and we start seeing the actual shape of the data. And once we start extracting these features using small proxy models, the truth just becomes impossible to ignore. Take 2 incredibly popular datasets, for example, SQUAD and multi-NLI. On a flat spreadsheet, they might seem functionally similar, but when you map out their data profiles across these 6 dimensions, wow, one dataset might show the smooth, predictable curve, while the other is just highly erratic and jagged. They possess radically different underlying data distributions. And this proves that evaluating over 100 machine learning models totally blindly without knowing the specific data topography is fundamentally broken. Honestly, it's like driving a sports car blindfolded at 100 miles an hour and just assuming the road is perfectly straight. You have to know the shape of your data if you want to survive the drive. Taking this all a step further, researchers can actually calculate the standardized mean difference across these 6 features. This mathematical process generates what's known as a data similarity vector. But what does this mean in real, everyday terms? Well, it's pretty revolutionary. It means we stop guessing when an AI will fail. Instead, we can mathematically map out the exact friction points before the crash even happens. By really understanding the specific differences between the training data and the test data, we can accurately predict exactly how much an AI's performance is going to drop when it faces unseen, out-of-distribution scenarios in the wild. We're moving from just, blind hope to true, actionable, predictive power. So let's bring it back to humans. Solving the human mismatch requires applying this exact same logic. We have to completely abandon those flat, standard communication metrics we talked about earlier. Instead, we need to architect what the source material calls symmetrical peer-to-peer alignment. And listen, this isn't just about, trying harder to communicate. It's a cooperative, structural, joint investment. The goal here is to deliberately design an interaction that secures mutual bioenergetic homeostasis. To put it simply, we are creating a communication channel that is structurally stable and high fidelity enough to actually carry that spiky, highly complex human data without triggering a biological crash on the other end. In practice, just look at the 2 radically different paths a single conversation can take. Imagine 2 individuals, let's just call them Dennis and Tom. If Dennis tries to have a standard, safe conversation using uninsulated, everyday verbal language, the payoff is honestly catastrophic. As you can see, it results in an infinite energy drain for the sender and a total prefrontal freeze for Tom, the receiver. The whole system just crashes. But what if they implement structured strategic proximity? Well, the dynamic flips entirely. By translating their content into highly organized algebraic schemas, both individuals achieve this massive payoff of plus 100. They literally hit a cognitive jackpot of 0 latency, visual compression, achieving total relational alignment without losing a single drop of data. The source text uses this brilliant metaphor to explain this shift, calling it the single M&M problem. Think about it. Standard social dynamics are kind of like being fed a single M&M when you are actively starving. Sure, you eat it, but you expend more energy to process it than you get back. The reward is tiny, it's exhausting, and it ultimately drains your metabolic reserves down to absolute 0. But the symmetrical solution, that changes the rules of the game completely. By delivering a highly structured specification instead of just messy small talk, you create a maximum magnitude reward. In fact, according to studies from HHMI and Harvard cited in the text, this structured alignment instantly triggers an extended dopamine wave and a one-shot prefrontal update. We're talking about the profound difference between cognitive starvation and a full-blown metabolic cognitive jackpot. Okay, so how do human geniuses actually implement this alignment out in the real world? Well, they rely on 3 distinct protocols. First up, Protocol 1. Close the open-loop port. You basically have to establish a zero-trust firewall to prevent bioenergetic leaks and protect your core energy from those standard, totally draining interactions. Next is Protocol 2. Standardize your PREP scaffolding. This just means structuring your data meticulously using the PREP method. Point, reason, example, point. This specific sequence acts like a literal key to safely bypass the receiver's biological brakes. And finally, Protocol 3. Co-create symmetrical sandboxes. Kind of like Lego therapy, this involves setting up a highly structured environment with really clearly defined roles, like, say, an engineer receiving data and a supplier providing it. Having that strict definition is what makes the transfer of super complex ideas entirely safe and efficient. So, the ultimate takeaway of this explainer is basically this truly unified theory of alignment. Listen, whether you're painstakingly tuning a natural language processing algorithm or you're trying to navigate highly complex, neurodivergent human relationships, the universal rule remains exactly the same. We absolutely must stop forcing spiky, brilliant, dense data into flat, standardized boxes. It just doesn't work. Explicitly structuring your communication channels and really understanding the true dimensionality of your inputs is the only way forward. It's the single key to unlocking massive predictive power in our machines and, more importantly, securing those life-changing cognitive jackpots in our human interactions. As we wrap up this look into the wild overlap between artificial and human intelligence and really examine these bottlenecks that limit our most profound potential, I want to leave you with a vital question. In our relentless, society-wide pursuit of standardized metrics, are we actually capturing true capability? Or are we just desperately trying to maintain an illusion of uniformity, leaving our most advanced models and our absolute brightest minds entirely bottlenecked in the dark? Something to think about.